activity 5. Go ahead and do this first problem. Suppose you flip 2 coins. What is the probability of the first coin landing heads up or the second coin landing tails up? And we have talked a little bit about this yesterday. We said that and is a little bit easier, has less normally chance of happening. When we do this with or, it's going to have a greater chance of happening, but we're going to have a little bit more work to do with it. So let's just go ahead. What are the 2 events? What are the 2 events?
If you flip 2 coins,
But I need 2 events. First one is what?
Heads or tails?
No. Thank you. First coin landing heads up. That's my first event. What's my second event?
Landing on tails.
Second coin landing on tails. Okay, you got to be specific when we're doing these guys. So let's complete this table. What happens? What are some of my possibilities? This is my organized chart. What can happen in this square right here, this rectangle? What happens right here?
The first coin has to hit heads.
Heads, and the second coin would hit what?
Tails.
Look at this box. Heads is right here. What is this row right here? So that event is heads, heads. What is this box right here? Nope. Guys, organized means that there is an order to this. You can't just throw out T because you see T first. What does this say right here? First coin. So that means that I have to put what first? H. What does this say right here? Second coin, which is? Doesn't matter the order. Yeah. Okay, so it's okay. Now let's try this box right here. What is going to be my first event that's happening?
Tails.
A tails. What is my second event that's happening?
Heads.
Does that make sense? How are we doing on this?
It's like a Punnett square.
Yes. Okay, what's happening right here? Tails, tails. That's how we organize lists, and whether it's in science or math or anything like that. If they give you a chart like this, and it says years over here, and then it says money over here, you match up the year, you go down, and this year they made that much money, right?
Yeah.
The first coin is the first one. That's going to be the first thing. The second coin is going to be that, right? Make sense?
Oh.
You have to pay attention to the headings.
So.
All right, now, it says draw a circle. You should be doing this on your paper. That's why you guys got these books. It says draw a circle around the outcome that matches the first event. What was the first event? First coin landing heads up. And it says draw a what around it? So, heads first. Is this heads first in this box? So let's circle it. Is this heads first in this box? So let's circle it. Is this heads in this first box? Is this heads first? No. Is this heads first?
No.
Okay. Now, it says draw a rectangle around the outcome that matches the second event. What's the second event?
Tails gets first.
Tails. Second coin.
More detail.
Yes. Okay. Attention to detail. I told you, these questions are not hard. They are tricky. And the reason that they can be tricky is because the attention to detail is not very great. And that's where you're going to make your mistakes. You've got to tune yourself to those details. Okay? Second coin landing tails up. This second coin, is that tails? Is that tails?
Yes.
So would they say draw a?
Rectangle.
Is this second coin tails? Is this second coin tails? Now, I already showed you a little bit of this yesterday. Yes? What happened here? And that we're trying to discover something. We're trying to look at this. How many events are there that came true for the first one?
2.
How many events are there true for the second one?
2.
With me? If I add those together, how many events does it look like that there are that make it true? It looks like there's 4. Are there really 4 events up here that make this true? How many of them are there? There's only 3. Why does it look like there's 4? Bless you. And so what happened to this one that falls into both categories? How many times is it being counted? So what would I have to do to combat that? It's where we come up with our thing we talked about yesterday with OR.
Yeah.
What's the problem with OR? Is somebody or maybe a couple people are being counted twice. Is it fair to count it twice for my probability? So here's what you have to do, which we're going to come up with that in just a minute, but let's make the connection here. The chance of probability A or B happening. You're going to take the probability of event what? A. You're going to add it to the probability of B event happening. But what do you have to do at the end? You have to subtract the probability of A and B happening. Why? Because right now, this probability is being counted how many times? Twice, and we've got to remove one of them to make it the actual real. Does that make sense? No. How many events are there that make this true? How many events make this true? How many ands are there? So 2 plus 2 is? Minus 1 is? Makes sense. When you take, here's what I did in first period. Let's say we came up with brown hair and blue-eyed people. I don't know why I picked that. Okay. If we made a list of this, right? We'd have little Timmy. He'd be on the list. Right? Johnny. Beth. Jaden. Don't laugh at my mom's name. Okay. Over here, we have Kai. Sarah. Don't know where I'm coming up with these names. Timmy. Now, if I wanted to make a list of the brown hair or blue-eyed people, I would write all of these people on this list, right? I'd write all of the people on this list, but what would I have to do?
You have to find the ones that counted the both.
Timmy's getting counted on there how many times?
Twice.
So if I remove him once, then I accounted for how many. Does that make sense?
So do you just choose which category?
We're not going to come up with a list like this. This is what happens. The probability of A, the probability of B, the probability of A and B. You subtract it. You're not going to have necessarily a list like this. We're going to actually do the math behind it, where we're going to have like 1/4 plus 2/5 minus, and then the other. Now, why did I teach you and first? Yesterday's lesson was what? Probability of A and B. Why did I teach that to you yesterday? Because you have to use probability of A and B when you do probability of A or B. In fact, let's review what it was and why this makes sense. Okay, it should help us out. The way we did probability of A and B was we took the probability of A and we did what to it? Multiplied it by the probability of B happening. You with me? Hey, where you at? What happens right here? When I go to find the probability of A or B, what do I first find? What do I find second? What do I need when I go to find the probability of A and B? Don't I already have that?
Yeah.
And I just multiply them together, and boom, that's where this comes from. You guys following me? Okay, it sets up nice for this.
Oh wait. Do you also have to pay attention to whether it says find the probability of A or B and A and B?
Oh yeah.
Okay.
Total different list. Think about my example right here. What's the probability that the person has both? How many people make that list?
One.
One. How many people make the list if I have a brown or blue?
Round 4.
1, 2, 3, 4, 5, 6. You've got 6 chances when you go brown or blue. You only got 1 chance when you go brown and blue. Because there would be other people up here.
Yeah.
Like I would have a list of people who are not blonde. So I would have brown-eyed people. And they would be a list of people. And then there would be a piece of redhead people. I got you nice. Okay? We'd have a list of these guys. And I said, what's the chances of me pulling a person who has brown hair and blue eyes? There would only be one person out of the whole list of people that would make that would be true. So my probability of getting that are not what? It's not very good.
Very low.
Now, what if I said, what are the chances of pulling a brown hair or a blue-eyed person? My chances go way up. Does that make sense?
Yeah.
So big difference between and or.
So we have to look.
Every time.
Yeah, look.
Attention to those details. All right, this is kind of like what we've talked about. Let's go to problem 2. We already created our formula. Right here, sorry. A new holiday. In the middle of page 66. So, a new holiday, probability day, woohoo, is going to be celebrated at your school, so you don't even get the day off. Doesn't sound like a holiday to me. So it may be celebrated on any of the first 3 days of any month. Now, the problem now is to choose which day it will fall on. Of course, the day will be selected at random. First the month will be selected, and then the day. So, how many dates for probability day are in the sample space? We should use our counting principle. How many events am I going to be picking from? How many things need to be selected?
2.
The first one is a
Month.
second one is a
Day.
how many choices do I have for my first selection?
12.
How many things do I have for my next selection?
Yeah.
Which means a total of, it's amazing. Listen. Does everybody understand how we got our sample space? Now then it says go ahead, construct a model for them. Hurry it up. All right. So we are going to go to this. We're going to cheat a little bit and use this guy. If I was going to make my list, again, I would start off with January and list 1st, 2nd, and 3rd. February, 1st, 2nd, and 3rd, right? And make sure I did every month with every day with me.
Make the little tiny one.
Yeah, go ahead. Does everybody understand how we came up with this list? This is an organized list. Yeah, I would make my list on this one. If they ask you to do the tree, you could do the tree on it. You would have 12 start like things at the top with little 3 branches off each of those 12. right? Because so it would go January, and then off of it would be 3 branches, 1, 2, 3. February, 3 branches. So either way, it doesn't matter. As long as you understand it, we're good. All right. So that's that. What's the probability that January 3rd will be chosen at random? How many January 3rds are there?
1.
How many outcomes are there total?
36.
So what's the chances of it happening? Okay. What about May 2nd? What about any specific day a specific day in a month will be chosen at random?
1 out of 36.
1 out of 36. Now, study the sample space. Let PA, so anytime you see PA for this problem, what's the probability of A, represents the probability of randomly choosing a summer month. And let the probability of B represent the probability of choosing the first day of the month. So what is the probability of A happening? Be careful because they're switching us up a little bit on this. Let's go back to our list. I don't like this problem,
Yeah, because
the way that it's worded, but I want to do it this way because not everything is always going to be equivalent. Here's what I mean. Maybe they give you a different list. Let's say we have a different list up here. Oh wait, I didn't have my list. Let's say I have my list right here. What if they did this? Like they give you the list. It's not like they said it, and so it's got this. Now, are my chances of picking a day that's a summer month the same as all the others?
no.
So before, when the problem is equal, when every month has an equal opportunity to be chosen, you can say there's 3 out of 12 months, and you're going to get 1/4, which is the same answer we're going to get when we do it the other way. But if I did this way, does June have an equal opportunity like all the other months?
No.
Do you get what I'm saying? Why does June have more chances of being picked? There's 2 more days that can be picked. If I pick this day, is it a summer month? If I pick this day, is it a summer month? If I pick this day, is it a summer month? If I pick this day, is it a summer month? Yes. What is the probability of A asking that it has to have? Summer month. So what you should do is you should go to your list and go, okay, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 chances of it being a summer month out of 36, which does reduce down to that 1/4 that we talked about. But do you understand why I can't go, there are 3 summer months out of 12, which equals 1/4. Why is it the same in this one here as it is over here? Because every month has only 3 days. If one of the months had had an advantage, like June, would this have turned out to be the same as this over here? No. So this is why I have to do this problem this way. I've got to count how many there are versus how many days total there are. Are you following me? You guys with me or no?
Yes.
Okay. Yes, sir.
So could you have done the 3 out of 12?
No.
Oh, just because, like, you did all of this.
But I don't want to teach you because I want you to think about because it won't always work. Because not everything is always going to be, like you're going to have some list that maybe, June 4th and 5th and June 15th is the best day ever.
Birthday?
Maybe. Or it's just the day the earth was blessed. Alright? Does that make sense? Yeah, make sure you guys know where I live, so just send presents. Oh, yeah, thank you. I have that on recording now. I know exactly whenever my house gets rocked. Just admitted to it. Yeah, there you go. If you've ever seen my house, it won't hit through one of my windows because I have too many trees in the way. Eventually, I'm going to take care of that, but whatever. All right, you guys with me on this? Now, what is the probability of B say?
First day of the month.
First day of the month. Okay? How many of those are there? Out of, which means I have a chance of. Does everybody understand where that's coming from? Okay. Now, what does it say next? We already did that.
Yeah.
Next one says calculate the probability of A and B if you're going through your book, correct? What is that? Huh? C. C. Should be flipping over to the next page, right? Top of the next page. Probability of A and B. What would have to happen for A and B to be true? It has to be A, summer month, and first day. How many of those are there? 1, 2, 3. This guy, and this guy. Out of how many days total? Which reduces down to? With me. How do I calculate? How do I calculate? By the way, if I didn't have my list, what was the probability of A happening? What was the probability of B happening? What's the probability of A and B happening? Is that what we found it true to be? Yes? So we don't have to have a list. We can actually do this with just the math. So what's the probability of OR happening? What did we learn? What did we learn? What do we got to do for OR? You add probability of A and B. They get a half here. Do they show that though?
No.
No. So let's do it. Probability of A happening is
1/4.
plus
1/3.
minus
1/12.
what? What do I have to do before I can do any of that really? Common denominator. That middle school work coming back? Why do I have to learn this? Oh, because you're going to use it later on? So we get 3/12 plus 4/12 minus 1/12. That turns into 7, right? This plus this is 7 minus 1 is 6. Out of 12, which reduces down to 1/2. How are we doing? Thumbs up? Sideways? Thumbs down? Way up. All right. So they do this right here. This is the addition rule of probability. And it says what we talked about before. Probability of A or B happening, you take the probability of A, add the probability of B, and subtract the probability of A and B. And they do... Alright, so now this one. This is just to show you that this can happen. What's the probability of choosing a summer month or a winter month? So, what are my two events? Summer event, winter event. Right? What's the probability of choosing a summer month? Summer months are there. So if there's 12 months, there's 4 seasons. On average, they're 3 months each. Now, some of them start in the middle. Right, in Florida we just have 1 season. Which I disagree. I feel like we have 2. We have 2. We have a summer and a fall.
No, it's more like a spring and a summer. I mean, when you say also fall. Yeah.
What's the difference between fall and spring?
Well, things are.
Fall's when things are shedding. Springs are when, things are growing. The rabbits are out there. They're, Anyways. With me? Okay. So if we were doing this, now what did I say be careful of? Because this problem is still referring back to that. Don't go to their van for candy. What have I told you about this for their summer, like for this specific question? I don't want to say 3 out of 12. Because could one of the summer months have a better chance of being picked if they didn't all have 1, 2, 3 days? So, but they do. But I want to be careful of that. I don't want to set you up for another question where they give you a list and they're not equal, and you go, oh, there's 3 months out of 12, so it's 3 out of 12. Yes, that will work in this case, only because every month only has how many days that they can choose from. So let's say this. Let's say every day we have 365 days to choose from. What are the chances of picking a summer month? Is it 3 out of 12? No. Because February only has how many days? 28. Are you following me? So I'd have to count how many days there are that are in summer. Divide that by how many days total there are. Are you following me now? You with me? So, how many days are there on this chart that are summer? Out of, which does reduce down to what you talked about, plus how many days are winter? Correct? How many days, what else do I have to subtract? What else do I have to subtract?
The probability.
Okay. What's the probability that you're going to pick a summer and a winter month?
1/2.
What are the chances of me picking a summer and winter?
No.
Can I pick this day and go, oh, that's a summer and a winter? There's no chance of that happening, correct?
Yeah.
So what does that mean I'm going to be subtracting?
0.
Is that a possibility that there is no overlap for my ors? Is there a possibility that no one satisfies both lists? So I'm not taking anything away from it. Yes. 18 out of 36, which is 1/2. Yes. But they can phrase the question to you. They're going to say, what are the chances of you picking a summer day? Or they can even say, what are the chances of you picking a day that falls in summer? Okay? And it's going to sound like, or even they can say, what are the chances of picking a month that's summer? You're still going to have to break it down to the days. Because all the months are not equal. Yes. You can, but it might make it. Each one you're gonna have. Like, that's what I said about these problems. These problems are not hard necessarily, but they are tricky. You do have to take your time and think through the wording of them and break it down. All right, so here we go. All right, this one we got something new coming up to it. Go to problem 2. Oh, I went way past it. All right. You've seen that you can use the addition rule for probability to determine the probability that one or another 2 independent events can occur. So, you can also use this rule to determine the probability of one or the other of two dependent events occurring? Let's find out. So, suppose you have 3 yellow, 1 purple, and 2 gloves in your drawer, because you just like colors. Okay? And you just throw them in there. Evidently, you lost one of your yellows and one of your purples, because normally they come in pairs. So, for some reason, yellow and purple, they got lost. So you reach into the drawer without looking and randomly choose 2 gloves at one time.
Because we all do that.
Right. Just reach in there randomly, choose it. Now, does the action of choosing the first glove affect the action of choosing the second glove? If so, how? But does it affect my second glove? I'm going to have to... Can I grab the same glove twice and satisfy 2 gloves? So does it affect it? Yes, because when I pull, I can't pull out the same yellow twice. When I replace the glove, when I pick one glove at one time, and I put that glove back in, and then I go back and pick again, could I grab that same glove twice?
Yes.
Yes. Can I grab the same glove here twice? Okay. So just keep that in mind, unless you are Houdini. All right. Write an organized list for this. So here's how I would attack this problem. Please pay attention to this. So, do you remember how we talked about subscripts in math? Subscripts are ways of organizing it. They have no mathematical meaning. Superscripts, which are things that are up in the top, have mathematical meaning. We call them exponents. But a subscript has no mathematical value, but we use it to help us for organizational. We are going to use subscripts here. This is going to represent yellow. Right? How many yellows do I have? So, can I choose yellow for my first glove? Can I choose a different yellow for my first glove also, though? So what would I do for that? Call it Y2. That's the second yellow. And I also have a Y3 that I could choose. And these are very good Ys that I have up. If you flip them upside down, they could be the claw to grab your glove out of your drawer. Out of your drawer. All right, you ready? What could be the next thing I could pick? This is going to stand. What colors do we have?
Yellow, purple, blue.
Okay, so we'll do this for purple because that makes sense. I'm really trying to mess with your brains. Now, do I have to do a subscript on this one?
No.
Do I have to do a subscript on this one? Why? Only one purple. Next one. I know. It's like those IQ tests.
Yeah, that's what I'm thinking.
They tell you to say the color of the writing and not the word. All right, you with me? Now, when I choose yellow first, I choose my yellow one first. What else could I choose with it? I could choose yellow 2, right? I could choose yellow 3 with it, yes? I could choose. Are you with me on this? So I have, with this Y1, how many different choices do I have with it? So I could write it 1, 2, 3, 4, 5 times to start off with, right? And then I go, okay, purple, now blue 1, and blue 2. Here I can go yellow 2, 1, 2, 3, 4, 5. And I could choose yellow 1 with it. I could choose yellow 3 with it. I could choose purple with it. And I could choose blue 1 and blue 2 with it. You guys following me on this? Yellow 3. Could choose yellow 1. yellow 2, purple, blue 1, blue 2. Does it make sense? Do you see how I made this chart? So I'm not going to finish it. That's good enough. We're going to go with this guy right here. Boom. Does that make sense? And actually, let's finish it just for us. All right. No, not. All right. So then it says, describe the events in this probability situation. So if we look at this, describe the events. Use the sample space to determine the probability of randomly choosing a yellow glove first or a blue glove second. So, what are our events? First event is choosing a yellow glove first. Second event is choosing a blue glove second. With me on that. Then it says to go ahead and draw a circle around the outcomes that match the first and a rectangle that matches the second. So do you see how they circled all of these yellows? With me. Then they took and boxed blue second, blue second, blue second, blue second, and then all these blue seconds down here. These didn't get boxed up here because they are not blue second. You with me? Yes? No? Maybe so? Okay. Now it says, what is the probability of randomly choosing the yellow glove first? Well, if we go up here, how many yellow gloves are first? Well, this would be 15 out of how many total are there? Why does it make sense that there's 30 events here? How many gloves do I have to choose from the first time? 6. I have 2 events that I'm going to fill the holes up. How many different ways of choosing the first event?
6.
How many different ways of choosing the second?
6. 5.
Right? Because I'm once I pick a glove, I can't use it. So 6 times 5 is, and that makes sense because I have 30 different options down here. Correct? Okay. Now, when I do 15 out of 30, that reduces to a 9. What's the probability of choosing a blue? So I come up here. How many blues are there for second? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 out of, or 1/3. Because 10 out of 30, right? Reduces to 1/3. You guys following me? What's the probability that A and B are chosen? 1/3. How do we find probability of A and B? Let's make me throw something at you. Multiply probability of A, which is right here. Probability of B, which is right here. So what does that mean it is? Should be 1/6, but that's not what they got.
Well, 2 times 3 equals 6, so.
I know.
Oh, I added
No, you should not add them.
6,
See, I had a problem when I did this question. I'm going to go over it with you tomorrow. I'm going to talk to someone. Because when I did this problem, I did not get this 1/3. But when you count it, it gets 1/3. When I counted this, I got... So let's talk about it. This is what happens. Let's make sense of it. Let's see if we can figure it out. What happened here... Well, they